Alright. It's not just a mean. Yeah, but it's a mean between two different.
Well, you find both of them. You find mean of both brand.
Yeah.
Brand A, brand B. But make sure it says population, so therefore you want to be able to know the form, even though you get the same answer, for example, in population, make sure you put the actual population formula. Because it's telling you it's population.
Since isn't mean calculated when we have two different brands?
Yes.
Oh, okay. I apologize.
If you write it down, it will help you. If you just put mean equals 35, I have no clue what you just did. If you write it down, work it out, just like that equation we share. It's not for me, I know what it is. There's someone that will read it. Somebody that will see it.
No, I think this is right. What's A? I wish I had
Yeah, you want to bring calculator next class. Just,
First and second class? I'm assuming they'll all be. Isn't it? Yeah, no. It sounds good.
This is chapter 3. Yeah, well, part of chapter 4 is in it too. Okay, yes, you're right. Geometry. This is population. So put capital N. Right?
Yeah, minus. The highest minus.
So you got a calculator, right? And use a hot method.
So, yeah. Yeah.
Okay.
Oh, yeah, this is it.
That's 25 of right?
The thing is that normally refer to the older form where
Yeah, we'll go over it. Just take that 10 minutes, make some mistakes. And the next one might be a little longer, so you want to tackle one step at a time. Yeah, it should be 210.
Makes sense.
It's only 5 minutes. 210. More than 10. It's just a population, so make sure you have the formula. Oh, you know. Yeah, you're fine. But then it's supposed to be sum.
Well, yes, yes.
Maximum minus minimum divided by 2.
Oh, for second one?
Yeah.
Yeah.
The first one, for each category. Yeah.
Which one? Is there some more? I have no idea what, I took this one. But we did this in the previous class. We did this. The same equation, but only 1 gram, so this is 2.
Yeah.
Yeah, for second?
Minimum or maximum minus minimum. That's it for race. That's it. For maximum. No, look, I got it. No, that's mid range. You're taking a mid range. That's what I did too. That's what I did. We were saying the same thing. I'm not sure.
It's only online now. You look that one there, Mike. Let's go.
And that's all it's asking. Okay. Oh, okay. This is what Yep, time to bring up the phone.
Oh, yeah.
I got it. Oh, you need the fax? Real close right now.
X minus one. X
I got right here, Tom.
10 minus 35 and then.
Variance is just standard deviation.
5 more minutes.
Yeah, what is it? Variance on the next page, but
No, the thing is that as I told you, I prefer to go to them. But I like to do
we got 2 different, there are actual ones you can use. And I'm not sure if there's two variants. What's on?
Sample variance.
What's your response? 35. So population, right? Population. Okay, so population is mu equals. Mu equals. That's what it's on.
That's very simple.
Yeah, that's important. Yeah,
So what is it?
Yeah,
Well, that's what
yeah, exactly.
samples you want to population, right?
Yep, you can use either one, you want to use the one that just has, set that.
What's the sample?
Is it down?
Two.
Because that's the one we.
Because x bar is one sample, so mu equals the sum of all x divided by kappa in's population.
And,
If you go x bar is for sample,
yeah.
Yes.
you wanted to put mu instead of that x bar.
Wait. Just say it.
Yes, the question says population. The question says, yes,
Obviously, so we're going to populate, yeah. Yes.
you'll get the
And it's
same
whole
meaning,
group, yeah.
but your standard deviation might be different.
Yeah.
We do this. Well, we're going together. So the sum of all of them is 210, right? 210,
Uh-huh. Oh, yeah. Yeah, I don't know, it was for the, we had minus 35.
No, back population. All the way down, no, you're right, you got it, all the way down. Does it say, I'll do that. Oh, you were there.
Oh, this
You were
is
there.
not
I was like, no.
not a formula. What it is, not a
See what it says, so the sum of all numbers, whichever point.
Yeah.
Oh, I got it all right here.
Because you're dealing with example 1, example 1 is the population. So they stick with the population, so therefore,
The sum would be two
it's
cents.
right there. Yeah, this guy.
And this one here is
No, 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 two is
mean, right?
The mean, that is
two
correct.
equals the sum of all.
For this one here, for
That's
everybody.
just that's what population, that's what we're trying to solve.
Each variable,
Each variable.
yes.
So each one of them, right?
Exactly.
Minus each of them?
Each one.
That's what
Each
that's
is
what
minus
I'm
one, right?
is
So
Yes, each one
that's
is
divided by
very-
six.
Exactly.
Minus each of them, and then you get the answer, square it, base.
Yeah, we're gonna use one.
Oh, this one.
But that is correct. Yeah, with this one. Well, no, because that's, yeah, that's it. About a minute? We'll go over it.
Yeah, it's a good thing we're doing this, okay?
Yeah, and then when you put the square.
Yeah.
Oh, yeah, that's what it was. Sum of x.
What's that always the population?
Subtract from the mean, look at this equation. So population varies each individual by x minus the mean that you just found of number 1, which is 35. So 10 minus 35, 60 minus 35, all the way down, then you get a square about subtract.
What I'm doing is that, now you have to square each of them, right? After you get the required.
For one of them, yes. But remember, you're doing something in population, right? That is the
That's
variance.
not how to. Yeah,
Yes, the variance is the difference between individual variable minus the mean. For population. Population. These are 1%. What do you want? One is variance, one is standard, like a percent deviation. Standard deviation is square root of the variance. If you find the variance, standard deviation is square root of, square root of the standard deviation. No, we go all the way down separate. So 60 minus 35.
Yeah, you just wrote it out. Yeah.
Alright, let's get back here. I'll go over it. So if you made a mistake here and there, then that's okay. Hopefully you'll pick it up here. So number one, so the reason I have two type of paints or two different type of paints, let me have your attention guys, is just to see the variation of the paint when we get to do both of them. So let's do the mean for brand A. So for brand A that we have population, so you don't want it to take the sample mean. The sample mean is X bar. That's not what the question says. The question says population mean. So you want to stick to population mean. So that equals the sum of all my variables divided by the capital N, right? So I have 10 plus for the first one. So I have 10 plus 60 plus 50 plus 30 plus 40 plus 20 divided by 6. You have 210 divided by 6, which equals 35, right? So this is for type A or type of paint A. So for B, we'll do the same thing, right? The sum of all x's or all the variables divided by n, that will give you the same answer, but let's just 35 plus 45 plus 30 plus 35 plus 40 plus 25 divided by 6, I'll get 35 as well, right? So that's clear, right? Is that clear, that part? Okay, let's go to the second one. When we talk about variation, range also can be used to measure the variation, but it doesn't tell you, right? If I take the maximum of 60 and the minimum of 10, that doesn't tell me about the rest of the the number or the rest of the data in my brand A type. So I need to be very careful that range is not sometimes doesn't give you what you're looking for. So the maximum value minus minimum value. So the maximum for the first paint, I'll just call it A, 60 minus 10, that is 50, right? So range for B is maximum value minus minimum value. The maximum is 45, 25. So therefore I have range equals 20. Right? Clear? Right? So this 20 doesn't tell me anything about the rest of the data, so the rest of the guys here, right? The variation only measure the two output numbers, so the two far numbers within the data. So there's nothing in between that tell you what is going on. So the only thing we can tackle it is when we go to standard deviation and variance. So they'll take individual value or individual. Can I raise this?
Yeah.
All right. So I'll take individual variables with the mean. So we know that the mean for both of them, A and B, are 35, right? So the variance equals, this is what you wanted to be able to use, all right? If you use S, that is for a sample. The question says population, so you want to stick with sigma, okay? The sum of all x, individual x, minus the mean that you found from problem number 1, divided by capital N. Is that clear? All right. So if I do individual value, right, I'll take 10 minus 35, the square, plus 60 minus 35, the square, plus 50 minus 35, the square, plus 30 minus 35, the square, plus 40 minus 35, squared, plus 20 minus 35, the square, divided by 6, right? Because it's capital A. Is that clear? Go ahead.
It didn't say population here.
On what? It says example 1, right?
Is this the variance of the standard?
This is the variance.
Okay.
Does that make sense?
Yeah.
Yeah, it goes back to the first problem. All right. So sigma squared equals 1750 divided by 6. That is 291.6. Now think about it. If there is a unit for this scale, for this measurement, then the unit will be to the square, right? To the square point. Then we'll talk about why that doesn't make any sense in a minute.
So
But
that's the answer for
this is the variance. That's it. Then the standard deviation is the square root of the variance. So if I take 291.6, I'll have 17.07. Okay?
Wait, what's
That's standard deviation.
is that 1750 or 17.50? No, the other one.
1707. Is that what you want? Oh, this?
Yeah.
1750. 1750. So now, we did take care of any question? Any question here?
Can you do the second part one more time?
We'll do in a second, we'll do that for brand B. So we'll do for brand, go ahead.
Oh, so each one is 35.
Yeah, the U is
It's called mu.
Yeah.
Mu.
You? Okay.
Yes, so this guy is mu. Mu, yes.
And then between the average?
Yes, the mean for the population.
Oh, okay, so what's the difference in X bar?
X bar is for a sample. This is for
Oh.
population.
Okay, now that's why you said that, I get it.
Alright, let's do for a second brand, you know, go ahead, John.
Why is this squares for every set parentheses, or is it the square of the whole thing?
It's square everything. So right here, if you only have one data, right? If I only have 10 then I'll take that 10 minus the mean. But I have 6 data, I'll take each individual from the mean and I square it. Does that make sense?
Yeah, you do the same thing for deviation.
No, because deviation is the square root of the variance, so there's nothing you could do there. You take the square root of the variance. They're the same equation, one is a square root and one is a square. Let's do the second one, hopefully I'll bring something. Alright? So for number 4, so we're doing for brand B, right? So we'll do the same thing. So sigma squared equals the sum of all x minus mu divided by capital N. So if I take each individual data, 35 minus 35, a square plus 40 minus 35 squared plus 30 minus 35 squared plus 35 minus 35 squared plus 40 minus 35 squared plus 25 minus 35 squared divided by 6, right? Is that clear?
Are you
Oh.
doing the second one, the very,
I'm sorry?
are you doing number 4?
We're doing number 4, yes.
Variance?
Yes, number 4.
Okay. Are we gonna do the standard deviation for number 3?
We just did. Because standard deviation is the square root of the variance.
Oh, okay, that's what
So once you determine what the variance is, then you take the square root of that, and that should give you the standard deviation. This is 17.07.
Oh, okay, I got way confused there for 17,000.
No, 17.07. All right. So I'll give for this variance, I will have 175 divided by 6, that will be 29.16, right? Then the standard deviation square root of 29.16, that should give you 5.4 for standard deviation. Now, take a look at both of them. What can we conclude? What can you say about knowing that you have standard deviation of 5.5 and 17.07? What can you conclude? Looking at back to your data, number 1. What can you say? Just based on that last answer.
That,
Go ahead.
I got another answer.
Okay, that's fine. What is it?
It's 250 over 6.
250 over 6?
And I checked my calculations again.
Okay.
That's what I got.
250?
250 or so.
Okay, then you should raise your voice. Alright, what is it?
41.667.
6.7. You just call it 6.7. And the square root of that is?
It's 6.45.
6.45. Thank you. Okay, 6.45. I'm allowed to make a mistake, please. So we have 6.45 and 17.07, right? Look back to your data from number 1. What can you say about it?
brand A will last more than brand B.
On what sense? Well, true, but what else can you say?
Wider range.
Okay, that's the wider range. There's wider variation, right? Because here the variation is very small between each individual data, right? So therefore your standard deviation or variance will be very small. But here the variation is so huge that you will have a bigger standard deviation and variance. Okay? So if your data are very close to each other, then your standard deviation and variance will be small. Okay? If your data are too big or wide enough, then your standard deviation will be bigger. Right? So the variation between the actual mean and each individual is big. Yes, go ahead. Okay, so going back to our range, right? The first one we have what, 50? And the next one we have 20. They don't tell you anything about it. right? The rest of the data. So the idea of standard deviation is variance. You're considering each individual data with the mean, okay? So as you can see, if your data set too wide, or if there is huge variation within each individual data, then your standard deviation and variance will be very huge, as compared to if your data are very small or close to each other, then your variation will be small, okay? Does that make sense now? Okay, let's continue. Here. The only disadvantage with variance will be that unit, when it comes to unit, right? Because when you look at it here, if this happened to be some unit, right? If this, just take this question and say, this is the unit of minutes, right? Measurement of minutes, right? When I get to here, I'll have minute squared. Then that doesn't tell you nothing much about us compared to the standard deviation. Right? So standard deviation is the one you wanted to use almost all the time, especially when it's involved units, because your final answer, if I do here, take a look at I have 5 students, it take them this much to get here, right? If that's how long it take them, if I need to find the standard deviation, and the variance, then I will have 62.5 minutes squared. What is minutes squared, right? It doesn't say much about it. But when you take the square root of that, you will have the square root of 62.5 minutes squared will give you a single unit of minutes. So that says a lot about it. So when it comes to things involve units, it's very, variance is not good way to measure variation. Right? Unit minute squared doesn't say anything, just minute squared. What is minute squared? Right? So that is one disadvantage. But you still have to do that to get to standard deviation. So that's a summary. So this is what you guys a little bit get confused was. This is for a sample, X bar. Okay. If the question says sample, then you use X bar with ACE. Okay. If the question says population, which is in our case, then you'll use the population with sigma. Okay. So it's all come to the question, and you have to read the question very carefully. Go ahead.
And it doesn't matter which one you solve for, because either way at the end you can just square root or just.
Yes. So well, eventually you have to start with the variance because you need the variance to get the standard deviation. The standard deviation is the square root of the variance. So you need to solve the variance first eventually.
Wait, so the sample, the first one is just when you have one data?
Say more about it.
Like the population, you know how they're 2 different ones?
Well, this two you mean?
No, that one and the other.
Okay, this is for population.
Yeah, and the other side just if you have like one data, right?
No, you can have the same amount of data, but the only difference is n minus 1 and capital N.
Okay,
Okay?
yeah.
That's the only difference. Besides that, everything is the same in the sign, mu and x bar, those stuff. Coefficient of variation. Now, we did range, we did a standard deviation and variance, and now it's coefficient of variation. The standard deviation is a good way to see if there is a variation between data from the same population, right? So if I divided this classroom into 4 students of there's 20 students, and if I divided each in group A, B, C, and D, and we have each of them we have 7 students, right? 7 sample or 7 students. So this is sample 1, sample 2, all the way down to last one, okay? Now, this is a good way to compare standard deviation because you have the same unit, right? Because this data came from the same population, right? These samples came from the same population. So if I'm talking about minutes here or hours, then the unit will be hours all the way down, okay? All the way down will be hours, right? Is that making sense? But what if you have 2 different units? How do you compare? I can't compare this with something that has kilometers or miles, right? 2 different units, 2 different measurements, so I can't compare. But we can use coefficient of variation. When we have samples from 2 different populations, we can use coefficient of variation. And especially true when you have different units or units of measurement. Okay? Does that make sense? Standard deviation, I can do standard deviation, the variance for the same population. Because the same units, at least. You can start with that. But if you have a different unit, then you can't use standard deviation. So the only way you can do it is coefficient of variation. Coefficient of variation is the standard deviation divided by the mean. So if I have S for a sample, coefficient of variation, okay, sample CD divided by mean. So that's what coefficient of variation is. Standard deviation divided by the mean. Okay. So coefficient of variation is for population, right? Just like what we did for sample, mean, standard deviation for sample and population, coefficient of variation also for sample and population. Okay? And the other one is coefficient of variation equals mean, okay? Times 100, because usually you're dividing a very small number with a large number, so you'll have very, very small sometimes. So when you multiply by 100, at least you get some number. So the idea of multiplying by 100 is just to see the percentile difference within two comparison that you have. Now that being said, this is for a population. This is for a sample. Okay. Go ahead.
This is times 100 or 100%?
100%. Well, yeah. Does that make sense? Coefficient of variation. Sure. So the idea of coefficient of variation is that I can compare two units that are different, right? Two data. So if I'm taking the distance you travel here and the time it takes you, right? I can use two of them with different units to measure, right? But if I'm pulling data from the same population that has the same unit, I can use standard deviation. And I can use coefficient of variation to compare between group A or B, right? I can compare within this two group because it's the same unit. But the benefit of coefficient of variation is when you have some different unit, right? If I have hours to take you, the time it take you to get to school from home and the distance you travel to get here, two different units, right? I can't use standard deviation to compare the two, but I can use coefficient of variation to compare. Go ahead.
Can you give me an example of coefficient of variation, like a problem?
Yeah, we'll do that one right now. Okay. Is that clear, the concept?
Yes.
The concept is clear. Let's do number 5 and number 6. It's gonna take us 6 minutes. Alright, so the mean of a number of cells in a car over a 3 months period is given to us 87. The standard deviation is 5. The mean number of the commission paid out is 52.25, and the standard deviation is 773. Compare the variation of the two. Now you can look at it here. Say the first one is measuring money or amount, and the other one is measuring some numbers of how many cars were sold. So two different measurements. Now, is it a population or sample? A sample, right? Because 3 months period is not the whole year. So that's one way to be able to spot it. So let's just take a look at this, right? If there's a car dealer, someone who worked, he wanted to know if there's any variation between the amount he paid out to employees as compared to the number of cars he or she sold, right? So for car, the average is in 3 months period there is 87 with a standard deviation of 5. Amount paid out you have the mean equals 52.25 with standard deviation of 773. Okay. Now remember the first problem when we did standard deviation, right? The two brand that we have, one is more spread out and the other one is not spread out. So remember that when we finish this problem. Now coefficient of variation equals the standard deviation of the data divided by x bar times 100%. This should give me about 5 divided by 87 times 100%, which is about 5.75%. For the amount he paid out, or they paid out from for this employees, will be standard deviation divided by x bar, where 773 will be the standard deviation divided by 52.25 times 100% times 100%. Then you will have 14.79% or 15%. You can put it that way, that's fine. Of variation. Now, what can we say about this? Go back to number 1 problem that we did, or number 3 and 4, where there is more variation and less variation. What do we say?
It's wider.
Yeah. So if you have a smaller variation, then this is the data is more close to each other, right? So the number of cars they sold within 3 months period very tied to each other. So every day, if they sell today 20, tomorrow will be like 22, right? So they are very close to each other within the straight period of a month. Close to 87, actually. Here, the amount they paid out is higher. So there's a big variation for the amount he paid out. That means there is one employee or two employees who sold more cars than other employees. Right? So that's why you have that variation. Go ahead.
So if the variation is smaller, could you say that it's more accurate?
Well, close to the data, yes. Yeah, you can say that. But just they're more close to each other, each individual data. If there is huge variation, then that means the data are more spread out.
Could you also say it's more precise?
Sure. Does that make sense? So there is some employee who sold more cars than other employee. So there's huge variation here.
Or could there be more commission given out on a different type of car?
Absolutely. Absolutely. If you sell high price car, then sure. Yep, that conclusion also absolutely work. Sure. Great. Let's do the next one, 6. Well, this question says that height and weight of 2 individuals. So we're going to compare the height and weight of individuals, where we have the height is given to us. So this is 6. The height is given to us, which is x bar. The average will be 68.34 inches. And the standard deviation for that group of individuals will be 3.02 inches. What I want you to pay attention here on both problems is the unit. Okay? We're dealing with 2 units, so we're comparing between 2 different units, right? Here we compare money, or the amount paid out, to some number of cars you sold. Here we comparing units of height, or measurement of inch, with weight, right? 2 different units, right? So coefficient of variation lets you do that, but we can't do that with standard deviation. Yes, great. Now, that is for height. We'll go to weight. We'll have x bar will be 172.55 pound, and standard deviation of 26.33 pound. Right? So we're dealing with pound and inch. So coefficient of variation equals standard deviation over x bar times 100%, where you have standard deviation is 26.73 pound, divided by 17.55 pound times 100%. I have a question. Why do you think this worked? Or why do you think having two different units of measurement work for coefficient of variation? Okay, let me repeat that question. For coefficient of variation, we're dealing with different units, right? So why would it work for different units? Yeah.
Because it's based on the average and you're calculating.
Well, standard deviation also you consider the average with individual score. What do you think? It's nothing has to do with statistics, algebra question. So coefficient of, go ahead.
Well, you're comparing apples to apples and oranges to oranges, right? Essentially, I mean, they're two different groups.
Yeah, okay,
But
think of
they-
them.
But they are related.
Well, they just happen to be fruits, okay?
Well, but I mean, they're getting data on height and weight, which they're trying to,
Yeah, okay,
they're comparing the two.
true. But think about it. I'm dividing pound by pound, which is gone, right? So coefficient of variation is unitless. There's no unit for coefficient of variation. So that's why it's so good and that's why great that this method worked, right? I can cancel this, it's gone, there's no unit there, right? The same for inch, there is no unit there. So there's just number, 5 equals 5, right? Does that make sense?
Yes, got it.
Cancel the inch, there's nothing there, so coefficient of variation for this guy would be 4.49%, and for this individual would be 15.25%, right? So the same, or we get the same closing of answer with the previous one. But it is true that to find people twice as much as your weight, not but as much as twice your height, right? Right? It's rare to find a guy that is 3 feet tall. I mean, 6 to 8, 9 feet tall, right? But you can find people that is twice as much as your weight. Go ahead.
So you forgot 2 for 170.
72, yes. Right? So that is small variation tell you that it's very rare to find individuals twice your height. Right? If you're 5'6", then you can't find an individual that is 10 feet and 2 inches or 4 inches, right? That's rare. You may find 1 or 2, but it's very rare. But on this variation, you can find individual twice as your weight. So the beauty of coefficient of variation is that you can deal with 2 different units or 2 different measurement of units where you can cancel and become units.
We don't have to round those, right?
No, that's fine with 2 digit.
Okay.
If you put a 4.5, that's fine. If you put 15.3, that's fine.
If we round it, okay?
That's fine, yeah. The web assignment will ask you specifically, like on paper, if you can get this process, then that's not a big deal for me. Go ahead.
So like, when you have big variation, that means it's more common, and if you have smaller variation, it's more rare.
Depending on the problem. On that problem, we're dealing with the number of cars sold with money, right, how much you get paid, and then we're dealing with weight or height.
So it
So
all
you-
depends on the problem.
It's depending on the problem, what kind of conclusion. She said it's also you can sell high commission cars, right? High price car, then you get more commission, right? If I sell 10 cars and she sells 10, so I happen to sell 2 cars that is more expensive, my commission is high, right? So it's also, it's just the problem will let you run with it. Sheva Shaftiran. We kind of did this a little bit, but let's talk about Sheva Shaftiran. I did go over on normal distribution or bell-shaped distribution or symmetric distribution. In our book, that doesn't exist anywhere near besides Chebyshev theorem, which doesn't make any sense. But we already did that, so I'll just go over what this theorem means. So this works on when you have data, any kind of data, it can be a normal distribution or skewed to left distribution or a U-shaped distribution or a uniform distribution, right? It works with all kind of distribution. Real distribution or symmetric distribution or normal distribution, as we call it in chapter 5, only work for a normal distribution. So those empirical rules only work for a normal distribution. Chebyshev theorem works for any distribution or any kind of distribution you may come across. So what this says is that the first thing, that 1 over k squared, we know that k cannot be 1, right? Otherwise it will be 0. So that's one thing you wanted to pick up out of this. The second one is, think of k, how much you travel away from your mean. Right? How much you travel away from your mean. So if this is my mean, right here, right? If that's happened to be my mean, now how far I travel, how many standard deviation did I add it to the mean to get to some maximum value, and the other side around some minimum value, and that distance you travel is k. Okay? So when you have k equals, so within 2 standard deviation, 75% of your data will be, let's just deal with population. So if I have a population mean, the first one, this guy says that within 2 standard deviation away from the mean, this, standard deviation minus mu 2, right? I can't have 1 because I'll be 0. Right? So the first thing I'm telling you is that within that, away from the mean, what am I doing? Right? So what this says that this is your mean, 2 standard deviation away from the mean plus your mean will give you 75% of your data to be within this 2 range. Okay? So if this distribution happened to be U distribution or symmetric distribution, that says 2 standard deviation away from your mean, that you will have 75% of your data within that 2 standard deviation.
That's the same thing you showed us with the skew, right? Yeah.
Well, yes, with symmetric, that's only for empirical rule where you have a normal distribution, right? That worked for only empirical rule, but this guy worked for non-empirical distribution or non-normal distribution, right? Okay, I can't have 1 because that's 0, so I have to go to 2. So with 2 standard deviation away from the mean, you will have 75% of your data within that group. This is just approximation, right? Sometimes you might not have the exact value, but approximately within that 2 standard deviations. And the same 3 or 4, the more you go down, where for 3 standard deviation away from the mean, we have mean minus 3 standard deviation, and somewhere here the mean plus 3 standard deviation. Within this guy, you have about the third one, which is 89% of your data, or 3/4. Okay. So within this, you will have 89% of your data.
So that problem is saying all of that, 75%, 90%, and 93%?
Yes, so 75, 89, or 90%, 93%, that how many standard deviation you're away from your mean to get to that maximum value. Knowing that how many you travel will be how many k's you travel to get to your max or minimum. But if you happen to have a data that fall within 2 standard deviation, that says that within this minimum and maximum, 75% of all of your data will be here. Yeah? Let's do a problem. Okay, so survey for local companies found that the mean amount of travel paid out for managers and CEOs will be 0.25. So this is the average per month. So the unit of per month. The standard deviation for this group will be 2.2 per mile. It's a dollar money or money paid here per month. Using Chebyshev theorem, find minimum percentage of the data value that will fall between 20 cents and 30 cents. So the question says, what will be within the minimum of 0.20 or 20 cents and 30 cents with summing equals 0.25. Okay. So 0.25 is your average. So this is my average. Okay. That's the average. Now the question asking is that what percent of the amount paid out between the minimum of 20 cents and 30 cents? Right? So we need to determine if I have 1 over 1 k squared, how many k's did I travel to get to the maximum and the minimum? Either way you go away from the mean, you travel equal amount. Okay, so you'll get a positive answer, positive value for k. So the goal is to determine the percentile between these two ranges. Now you're probably thinking about it, if my standard deviation is 0.2 and it says here 2 standard deviation, right? Let me clarify that. When it says 2 standard deviation away from the mean, it means that you add in 2 standard deviation or 2 times your standard deviation plus your mean will give you the first k. Okay? That 0.2 is the standard deviation for that group of samples. Okay? Don't mix it up. This just says you travel 2 standard deviation away from your mean or 3 standard deviation away from your mean. Okay? Does that make sense? A little bit? When it says 0.2, this is what it just means. This right here is 0.02, right? Yeah, 0.02. That's what it is, right? Now you need to multiply it by 3 plus the mean will give you this value right here. That's what it means, okay? When it says 2 or 3. Don't mix the two things. Okay, if I multiply this by 3 plus the mean, it will give me some value. That's what we're going to do right now. Alright, so the first one is standard deviation will be 0.27. Now, this become a bit easier way to do. There's easier method, or I don't know if it's easier or for work for all of them, but if you subtract your maximum from your mean divided by standard deviation, that usually give you what k is. I just add the standard deviation to the mean.
So k is just a number?
K is a number, how many you traveled away from the mean.
So I got 2.5.
That is true. Yes. So k is how far you travel, right? So if I'm traveling here, so if I go 2 standard deviation away from the mean, this is k equals 1. 1k I travel. The next one will be k equals 2. I travel 2k to get to this point. And you do the same one, the other side. Okay? So if I keep adding what the standard deviation to the mean, then I should be able to determine what the maximum or what k is. K in this case is 2.5, which is true. 0.29, and the next one is, or the last one is 0.31. And I'll do the same thing the other side. I subtract down. So if I subtract 1 down will be 0.23, 0.21, and the last one is 0.19. So this one is our minimum, this one is our maximum, right? If my maximum was 31 or 0.31, then I traveled 1, 2, 3, 3.5 feet, right? Did I miss something? You travel 1, 2, this will give me, yes, yeah, which is 3. But ours is in between here. So we need to determine this half. Does that make sense? If this doesn't exist here, okay? How many kids do I travel from the mean? No, 1 right here, 2 right here,
Oh.
and 3 right here, right? I travel 3 kids, right? K equals 3. The same the other side. But our value is, because each goes by 0.02 increment. But our value is here between the two numbers, which is 0.30. So I need to account for that half. Right? It's not fully there yet. Go ahead.
Would we ever have a problem where, let's say this is the same problem, but instead of 0.3, we have 0.4?
Sure. Why not?
But what I'm asking is, then how would you compare? So K is from the mean to the whatever number.
Maximum, yes. Max or min.
Yeah. And
Now you might be overshooting because you might put all of your 100 data. By travel, if I travel K equals 4, I'm into 94%, right? If I travel K equals 5, I'll get to 97. So by the time you get to K equals 7, then you only include all of the data, so there's nothing you can do.
so K equals 2.5. Does it have to be true for both sides?
Yes,
Okay, that one.
has to be the same, yes. Either left you subtract or you add, has to be the same K. Good question. So K has to be equal both sides. Okay? So the way to solve this is, I'll take the maximum that I was given, which is 0.3, minus the mean, which is 0.25, divided by the standard deviation, 0.02. Which is 0.02. This equals 2.5, right? So that equals 2.5. So you travel K 2.5 away from your mean to get to your maximum point. So what we want to do is 1 minus 1 over K squared, where K is 2.25, 1 minus 1 over 2.25, or 2.5, 2.5, the square, that will give me 1 minus 1 over 6.25. 6.25 is the 6.5 is my common factor for both of this, right? There's 1 right here, so the common factor is 6.25. Then 6.25 for 6.25, you have 6.25 minus 6.25 for 6.25, it was 1 time. 1 times 1 is 1. Then you have 5.25 divided by 6.25.
Yes.
I'm good? Okay. This equals to 84%, or 0.84, which corresponds to 84%. So 84% of your data, or the amount that was paid out for these managers, will fall between the minimum of 0.3, the minimum of 0.2, and the maximum of 0.3. Where?
Okay, that last part right there.
Okay. So let's get back here. 2.25 is 6.25, right? If I take the common factor of the two, I'll take 6.25. 6.25 for 1 was 6.2 times, right? So I have 6.25 goes there. If I divided 6.25 for 6.25, I can only give a 1. So minus, the sign is minus, was 1, right? So I have 5.25 divided by 6.25. That will give me 84%. Okay? So 84% of my data, or the amount that was paid out per mile, fall between 20 cents and 30 cents. Go ahead.
What's the equation to find K?
You're taking the maximum value, so let me just, K equals taking the max value minus the mean. It's depending on which way you go. If I take this one, then I have to switch this so it doesn't have to be negative. Okay? But if you stick with the maximum minus, then the standard deviation. Deviation.
Wait, so how are we getting 6.25 on top? And it's the only thing I don't get.
I'll take the
It's when you
common
find
factor
Oh,
of the two, which is 6.25. If I divide it, if I only have one individual that I need to give 6.25, I can give the whole thing for that person, right? So think of this as one person, then you're giving it everything for that person.
oh,
Then you have 6.25. If I have 6.25 apples and I have 6.25 individuals, I can only give them one, right? 6 times, 6.25 times, so therefore it goes 1 here. Okay. So what we're gonna do when we come back, I think this is the last, so this is gonna take half of the classroom, which will be position measurement. So this Thursday will start probability on chapter 4. And that chapter will be a lot, we'll go a lot faster, not faster, but there's not much there to suck our time as this chapter did. So we'll try to have chapter 4 in the PowerPoint, and I'll add 4 and 5 next class, and we'll finish it. Make sure you pick up your homework. So this homework due next week. Okay? The online one, I'll fix the online one. So don't worry about the online one. Alright, I'll fix the online, I'll extend it because we did not finish. So homework is right here. If you didn't sign your name, sign your name. Right?
Yo, Jesse.
Yeah.
So, you're saying,
I'll extend it. The one passing here. Oh yeah. Ask for it. I'll give it.
So we don't have any homework till Thursday?
But it started this week. This is a huge package.
Okay.
I'm on the longest list.
Yep, they're all this. Yes. You too. Have a good day. Next Thursday. Next Thursday.
Tuesday?
Yeah, Thursday the coming week. In a week. Oh, yeah, one of those. Center. Yes. Sure. Wow. This is the quiz. And Tanya, do that. You send me email? Give it an email?
My homework that I can.
Okay. The grade posted on there.
Because they are equal, I don't wanna miss it, I just don't. Listening thing. I know, they are similar to the. In the back, in the back. Oh, okay, okay. I was about that, instead that's everything I don't wanna. This one, 2 of them, 2 of them. Yeah, this one.
Because I snapped it off.
The same thing, okay, you want that.
There might be some. Okay. I snapped it off. Okay, then let me let you know.
Yeah, check for me, the. Yes. Yes, it's 19. Yeah, for the loan, I did it, I seen it since when,
I did not take anything from,
the first
yes, I did not take anything from the website.
website, yeah?
Yes.
Oh, okay.
I usually wait until the first exam and then I take this one.
Yeah, because I had trouble with the web and I said maybe it didn't go through, that's
I
why.
did not take anything from grade wise. I
Okay.
didn't check if you did it or not.
Okay, thank you.
How many did you send the web assigned for?
But you don't have
The
yours?
web assignment chapter 3 will
I mean,
be
because-
extended for, since we'll finish this Thursday, we'll be on Tuesday.
Tuesday, will be good Tuesday, okay. My friend Mary, I was thinking about just doing, cause I don't get the question.
Question?
The
Oh,
coefficient of
Coefficient of
variation, yeah, I don't really
Oh, but
get that
that's-
much,
oh,
and
okay,
this,
but-
the ratio, but, so, I don't know if you have any of
Okay.
those homework
But
stuff,
this
so
one,
I
there is.
I put
There
it,
is?
yes, we got this one, you can.
So then I can try those and then I can just show it to you and then if I sort of get it and then.
I can look at it next week.
Okay.
Thursday, if you can give me
Yeah.
any problems now, because I don't get it. And the
Oh.
website doesn't work that well, so it's not like it gives me problems like my math. one.
Yeah, well, I have no control on that part.
No, I know that.
It's not to say, but there is, for everything that we covered, there will be a problem in it on the package. So there will be one for that has to deal with stereo shift theorem, one at least two.
Okay, I'll do it this one. Start early, it will exam on Thursday.
Standard deviation change.
So that's the most only that I can practice in, because I mean, the book doesn't give you problems, where web science sucks. And you're only given homework, which I mean, you're not supposed to give us extra, but if I don't get it, how am I supposed to practice? If I don't practice it, I'm never gonna get it.
Using cherry shift, there's cherry shift one here, another one here. Next question is. Cherry shift.
No, if it's there, that's
It
the
is
only
here.
thing you can check then, because the thing is I need help, if I told you I was gonna say it because I needed to learn that, not for anything else.
Yeah, no, I understand, so do you need more problem?
For Shavation, I mean, yeah, that's the
Okay, well, do you want it, do you want to give you on next Tuesday, on Thursday?
This is the Thursday too, though.
This is due Tuesday,
Tuesday of
Tuesday.
next week.
next week, a week from today.
So Thursday, okay, I can do that.
And then the online will be also that day. Next week,
The online homework is
Also
also
will
due
be
Tuesday
Tuesday.
of next week.
that is correct, because I
Okay.
gotta finish this chapter this Thursday.
Yeah.
So it's gonna take us 35 minutes, and then you have time to waste of which is, fourth question has to do with construction of percentiles and things like that. So that would be this Thursday. But anything that is started on page one down will have things we covered up to this point.
Okay. Alright.
That's it for sure.
No, not really. I mean, it's not helpful, but I guess I can wait till Thursday to see what I can get. Because the only thing that I need, the only reason I told you if you can say later was because I don't get that. Like, I don't get the coefficient.
Are you asking me, can I stay later?
Because I need to learn this. I
Sure.
don't know how am I gonna pass? We have a test like what next week also.
Yes.
So how am I gonna learn? I mean, if I don't get this clearly, I'm not gonna do well in the exam. The book isn't helpful, and I'm not going to a tutor because tutoring doesn't work for me. Like, I just need someone to one time explain, one time seeing it like really good. Even though it's really good, you did a good job today, by the way. But no, you really did. It was clear. Like it was. That's what I expect. So that was good. But that's fine.
Well, let's do the one we just did. Let's just go over it.
Because
Let's just do that one. Let's just clarify that.
all right, let's do that.
Sorry. So, when we talk about coefficient of variation, okay? So standard deviation, you're measuring it away from the mean, right? You're comparing with the mean. But this coefficient of variation is when you have units that is different.
So it's just when you have two different. Okay, just give me like random numbers, and then let me
Okay.
see if I can figure it out.
So
like that.
this is time, okay, unit of time. And I'll put it in second. And the mean equals 30. And it's a sample. Where the standard deviation of 2 second and second. And this is distance. And this is a mean. So the average distance is 600 with a standard deviation of 85.
So then from there I would do because what is it? Let me see. The problem is S over
Coefficient of variation equals the standard deviation divided by x bar times 100
times 100.
percent.
Let me do that. In the test, are you gonna give it like that, like XS? Like, are you gonna give us that in the test, or
No.
are we supposed to figure it out on our
You
own?
figure out from the problem, just like the way you had it.
Like reading it.
Yes,
out?
this mean equals this much.
That's. Oh Lord, so time. plus- So that is. Would that be right for the first one, 100? No, I mean.
We just came up with the problem, so
1500?
1500 first one
Yeah,
for this?
yeah.
No, because you divided, I know what you just did, you divided this by this, you got 15 times 100, that gave 1500. You go the other way around.
That's right.
2 divided by 30 times 100.
That is right. Okay, so this is gonna be 2. Okay, 2. That was a silly. And you don't care if we round, as long as if it's like that's 6.66. So I could just put 6.6 or 6.7 and
Sure.
it'll be fine.
That's fine, 6.7 is fine, 6.6 is fine. 7 is fine. No objection.
Alright, so the second one would be 14.6.
Coefficient of variation S over X bar times 100%. That would be S is 85 over 600 times 100%. You got 15?
I got, yeah, 14.1.
1, okay. Percent.
Okay. And then for the Shabasian one, I mean, that's, yeah, the Shabasian, that's the one with the X,
With the K.
the K, yeah.
So the idea of, I'll just call it Chebyshev theorem, okay, is where K is how far you travel away from your mean. Okay? So you're looking into some value of mean and then looking at your maximum, whatever maximum you're given, and whatever minimum you're given. How far do you have to travel by adding the standard deviation to the mean to get to your maximum point? So K represents the travel you make. How many K? So the first one will be K1, the second one will be K2, all the way down to the max you wish to. Okay?
Okay, so if you were to give it an, so you're just gonna give me something Thursday with like extra problems?
Sure.
Cause then like that I can do it, cause then like that you're not doing anything at the top of your head, like you have it and then I'll do it and then I'll give it back to you. Is that gonna even work though? Because that would be Thursday and then the
Oh.
test is next Tuesday.
I'll send you email by tomorrow.
You do that?
Not a problem.
Okay, and then I can just give it to you Thursday and we can go over it fast and then you can just tell me where my mistakes are.
Sure.
Because the thing is that I need to pass this class. And I really don't do well with tutors and I don't want to get out of my comfort zone to just go do something that I know I don't want to do. Because it's not going to work. I don't do well with tutors. So,
Sure.
if
No.
you
I'll send you problems from both sides.
just those two,
I mean from this too.
okay, that'll work. Because then like that, like I know. Because the thing is that I really need to pass this class. You don't even know like how badly I need to pass it. So, and I get it, but I just need to practice and that's it.
Sure.
Thank you. I'll check my email.
Sure.
Good afternoon.
You too.